Good morning friends. After the discussion of second law of thermodynamics and also the reversible and irreversible processes, now we are going to discuss about the Carnot engine and Carnot cycle, and we have to also derive the work done during the Carnot cycle or whatever the work done in Carnot engine. Now Carnot engine is also a heat engine which convert the heat energy into the work done. Right? So first our question is that what is the Carnot cycle? Explain with the graph pressure versus volume. Right? Now what is the Carnot cycle? A thermodynamic cycle in which the working substance goes from temperature T1 with two isothermal and two adiabatic reversible process to the state temperature T2. Such cycle or the such process is known as the Carnot cycle. Again, a thermodynamic cycle in which a working substance goes from temperature T1 with two isothermal and two adiabatic reversible processes to a temperature T2. Such process is known as Carnot cycle. Again, we repeat the definition of Carnot cycle: a thermodynamic cycle in which the working substance goes from temperature T1 with two isothermal and two adiabatic reversible process to temperature T2. Such process is known as the Carnot cycle. It means the Carnot cycle, here the two reversible processes take place, two isothermal and two adiabatic reversible process occurs. Such cycle is known as the Carnot cycle. We bring the system from temperature T1 to the temperature T2. Right? Already we discussed about the cyclic process, the process or the thermodynamic process in which the thermodynamic substance undergoes the numbers of the thermodynamic process and return back to its initial state. That is known as the cyclic process. Here the Carnot cycle is also the cyclic process or the thermodynamic process in which a system going from temperature T1 to the temperature T2 with two isothermal and two adiabatic reversible processes. Such process is known as Carnot cycle. The graph of pressure versus volume of Carnot cycle is shown in the figure. Here the graph of pressure versus volume. Initial state of a system is this. That is the first stage. In this stage, the pressure is P1, volume is V1, and temperature is T1. Now we bring the system by keeping the temperature constant, and we bring the system in the second state. Pressure is P2, volume is V2, temperature is same as the initial T1. Now we bring the system from second state to the third state. In third state, the pressure is P3, volume is V3, and temperature is now changed from T1 to T2. So that is the isothermal process, that is the adiabatic process. Now, we bring the system from 3 to 4 by keeping again the temperature constant. That means the isothermal compression, here the isothermal expansion. That is the adiabatic expansion, here adiabatic compression. Now listen here. So here we bring the system from third to the fourth state. In fourth state, its pressure is P2, volume is pressure is P4, volume is V4, and temperature is T2. We bring the system from 3 to the fourth state by keeping the temperature constant. Now again going to the initial state 1 by keeping the exchange of the heat constant, temperature is changes from T2 to T1. So this cyclic process is known as the Carnot cycle, and here this Carnot cycle is completed by the two isothermal and 2 adiabatic reversible processes. Clear this? So Carnot engine is worked on the base of the Carnot cycle. Again, the definition of the Carnot cycle: a thermodynamic process in which a working substance goes from temperature T1 to the temperature T2 with 2 isothermal and 2 adiabatic reversible process. Such process is known as the Carnot cycle. The graph of pressure versus volume for the Carnot cycle is shown in the figure. After that, explain what is the Carnot engine, or in other words, define the Carnot engine and also explain it. Now, the definition of the Carnot engine is that a Carnot engine is an engine converting the heat energy into the mechanical energy, that means the work, using cyclic process consisting of 2 isothermal and 2 adiabatic reversible process. Again, the Carnot engine is an engine converting the heat energy into the mechanical energy of the work, using cyclic process consisting of 2 isothermal and 2 adiabatic reversible process. So that is the definition of Carnot engine. The other definition is that a heat engine based on Carnot cycle is known as a Carnot engine. Again, a heat engine works based on Carnot cycle is known as Carnot engine, which works between two temperatures, T1 and T2. Again, we repeat the definition. Carnot engine is an engine converting the heat energy into the work or the mechanical energy, using cyclic process consisting of 2 isothermal and 2 adiabatic process. Again, a Carnot engine is an engine converting heat energy into a mechanical energy, using cyclic process consisting of 2 isothermal and 2 adiabatic reversible process. The other definition is a heat engine based on Carnot cycle is known as Carnot engine, which works between two temperatures T1 and T2. Now, the schematic diagram of Carnot engine is shown in the figure. There is the piston cylinder arrangement. Here the cylinder with wall are perfect insulated except the bottom is conducting bottom, while the piston can move up and down without any friction, and also the insulated piston. So the schematic diagram of the Carnot engine is shown in the figure. Here we consider the working substance or the ideal gas as an working substance. Carnot engine consisting of the cylinder whose walls are perfect insulated except the bottom and piston sliding without friction. Here the bottom is conducting while the wall and piston are perfect insulated, and here the piston sliding without friction in a cylinder. Now, a gas which is considered as an ideal gas is filled in the cylinder. Here the ideal gas we consider as a working substance. Now, it has the heat source with large heat capacity and high temperature T1. And also it has the heat sink with the large heat capacity at low temperature T2. Here the T1, that means the temperature of the heat source is much greater than the temperature of the heat sink. And also it has the insulating state. Again, the schematic diagram of Carnot engine is shown in the figure. Carnot engine consisting of a cylinder with perfect insulated wall except the bottom. The insulated piston can move up and down without any friction. Ideal gas is considered as a working substance which is filled in the cylinder. it has the heat source with large heat capacity and high temperature T1, and also it has the heat sink with large heat capacity but low temperature T2. Therefore, T1 is greater than T2. It has also the insulating state. So there is the block diagram of a Carnot engine. Right? Carnot engine is also a heat engine which converts the heat energy into the mechanical energy of the work. Using the cyclic process consisting of two isothermal and two adiabatic reversible process. Clear this? So that is the basic concept of the Carnot cycle and Carnot engine. Now we are going to discuss about the two isothermal and two adiabatic process. What are the exchange of the heat take place and what are the work done during these processes. Right?